Hello everyone, welcome to VectorX Academy. So today we are going to solve the question from 2018 advanced paper on the chapter gaseous state, which includes the concepts of your gas laws. Very simple gas laws. Okay, so the question says that a closed tank has two compartments A and B. Okay, they both are filled with the oxygen, and it says that we must assume that the behavior of the gas is ideal. Okay. So here in compartment A, the temperature is 400 Kelvin, volume is 1 liter, and the pressure is 5 bars. And similarly, in compartment B, the pressure is 1 bar and temperature is 300 Kelvin and volume is 3 liters. Okay, so if the old partition and if the old sorry the partition separating the two compartments is fixed and perfectly heat insulator. So here you see, right, this is the portion which is our perfect heat insulator it doesn't change anything in in between temperature. Like if the compartment A is already 400 Kelvin, then it doesn't change itself from 400 to anything. It remains simply as 400. Similarly, in compartment B, it remains as 300 Kelvin. Now, if the old partition is replaced by a new partition which can slide and conduct heat between, but does not allow gas to leak across, uh, the volume of compartment A after the system attains equilibrium is. So he's finally asking us to find the volume in this compartment or in compartment A. Okay. Now, he actually replaced this slider with a one which moves and which can conduct heat. Okay. So this is what is the question. Okay. Now to discuss about this, now first we need few concepts. Those are our basic gas laws. Okay. What are those gas laws? First one is Boyle's law. Second one is Charles law. Third one is Charles Gay-Lussac law. What is it? Charles Gay-Lussac law. Okay. And the fourth one is Avogadro's law. Okay. Here the name is like this Boyle's law, Charles Gay-Lussac law, Avogadro law. These all are the scientists. Boyle is a scientist, Charles is a scientist, Gay-Lussac is a scientist, and Avogadro is a scientist. Okay. And so first one, Boyle's law. What does this Boyle's law say? Boyle's law says that at constant temperature, it actually gives us the relation between pressure and the volume at the constant temperature. Okay. What does it say? What is that relation? Pressure is inversely proportional to volume. That means mathematically we can write that P is inversely proportional to V. This is what we write. Okay. Now, instead of this proportionality, we shall introduce our proportionality constant. K. Okay. From this we can write that PV equals to K. Let our if somebody give you a question like, if this is your initial compartment and this is your final compartment, okay, the pressure is P1, volume is V1, and pressure is P2, volume is V2, then if this process is done without the change in temperature, that means temperature is constant, then the relation will be P1 V1 equals to P2 V2. Nothing, just you apply, you just keep those terms in the Boyle's law, and then you simply, you know, uh, equate the constant, then you get this P1 V1 equals to P2 V2. Okay, this is how. Now, coming to graphical part of a Boyle's law. So basically, we all know that if a P, like if anything is inversely proportional to each other, then the graph will be obviously rectangular hyperbola. So the same thing happens between P and V. This is rectangular hyperbola. This graph name is rectangular hyperbola. Okay. Next, we saw that this is our mathematical statement. Now, let us apply log on both sides. Okay. Now, it will be taught in your math that log of AB will be equals to log A plus log B, and vice versa. Similarly, here also we are going to apply that. Then what are we going to get? Log P plus log V equals to log K. This equation, let us rewrite it as like this. Log P equals to log K minus log V. Okay. So, now let us construct the graph between them. This is our y-axis, and this will be in our x-axis, and this is our intercept. So, it's of the form c plus y equals to c plus x, where slope is minus 1, right? So, the graph will be slope is minus 1, and this total will be your intercept log k. Okay. Next, differential form of Boyle's law. So, first we differentiate it on both sides. Okay. We know that differentiation of any constant is 0. Okay. So, this will be 0. Now, how do you differentiate this? They both are actually varying. You know, above we saw the graph where the graph is actually rectangular hyperbola. See, they both are varying with each other, right? Then how do you actually derivate it? It's the chain rule actually. You know, d by dx of u and v is u times dv by dx plus v times du by dx. This is what our good chain rule says. Okay. Similarly, you're gonna differentiate it here. P dv plus v dp equals to 0. Then P dv equals to minus v dp. Okay. Minus p by v equals to dp by dv. This is your differential form. Okay, this is your differential form of the Boyle's law. Okay. Next one. It's your Charles law. What does Charles law say? See, Boyle's law had took place, when the temperature is constant. Similarly, Charles law takes place when the pressure is constant. Okay, it doesn't take place, but the experiment which we do, the conditions are like the pressure is constant, and we are gonna see what's the relation between the volume and the temperature. Okay, so now what did Charles observe from his experiment? He observed that, for every 1 degree rise, the volume increased by initial times by 273. Okay, this is how the volume increased. So with that we can come to the mathematical statement that V final will be equals to V initial S V initial by 273 whole times the temperature. Okay, the graph will be, see, actually we took the container like any vessel, then the initial volume is actually constant which we measured. Now we are actually seeing how does the volume varies, final volume varies with the change in the temperature. So this is your Y, this is your C, and this is your M, and this is your X. Then it will be the graph between V final and temperature. Okay, and this part is V initial, and the slope is V initial by 273. This is what your slope is. Okay. Um, and the interesting part is that as you saw earlier that uh, as volume is increasing, the temperature is also increasing. So we can write that V is directly proportional to T. That implies with taking V is, and we can also write V1 by T1 equals to V2 by T2. Okay. And next, our next law is Charles Gay-Lussac law. What does Charles Gay-Lussac law say? It's actually similar to your Charles law. What does Charles law say? There will be for every 1 degree centigrade rise, the volume will increase by initial volume by 273 times, right? Similarly, but the Charles law takes place at the constant pressure. Gay-Lussac law, it is also similar to Charles law, but it takes place at constant volume. So he observed that at constant volume, uh, you know, for 1 degree centigrade rise, pressure increases as P naught by 272. Okay, this is how temperature and pressure are. With that, we can write the statement that, I mean, mathematical statement that okay, this is our mathematical statement, and the graph is, you know, This is our y, and this is our c, this is our m, and this is our x. As we discussed initially, the v initial is some constant. Similarly, here p initial, which I wrote as p naught, is constant. Okay, so this will be p naught, the intercept, and this will be temperature, and this will be p final, and the slope will be p naught by 273. Okay, next, Avogadro's law. What does Avogadro's law say? No, Avogadro's law, it actually keeps both pressure and temperature as constant. Then what does it observe? Still now we saw the relations between pressure, temperature, and volume. What is the fourth quantity? It's our number of moles. So what does Avogadro's law say? No, volume is directly proportional to number of moles. How do we find this number of moles? See, number of moles given weight by gram molecular weight. This is how you find your number of moles. Okay. For suppose, if my the given molecule to me is H2, and if the given weight is 4 grams, then number of moles N will be 2, because 4 by 2 H2, the basic math. Okay. Then similarly, how we wrote for Boyle's law as V1 equals to constant. Similarly, we are gonna write V n but equals to V2 by N2. This is what Avogadro's law says. Okay, next. And I forgot to say, no, here I wrote that V1 by T1 equals to V2 by T2. Similarly, even for Gay-Lussac law, it's possible that P1 by T1 equals to P2 by T2. Because the direct variation, see, it's varying linearly with respect to temperature here, the final pressure. So with that I can say that P is directly proportional to T, or P equals to K times T. This is what I can directly say. Okay. From this is what, that's how I have come to that evidence that P is, you know, directly proportional to temperature. Next, our very good ideal gas equation, which will be again very useful while solving that question. Okay. See, basically, till now we saw that pressure is inversely proportional to volume, right? And pressure is directly proportional to temperature. Volume is directly proportional to temperature. And volume is again directly proportional to number of moles. Okay. From this, from all this, we come to the conclusion that PV is directly proportional to NT. Now we are gonna take out that proportionality constant. Sorry, now we are gonna take out that proportional. Then what do we observe? PV equals to nRT. No? What is R? It's your universal gas constant. See, actually, ideal gas doesn't exist, because the assumptions which we make in our ideal gas is such a way that there is no force of attraction and force of repulsion in between them, which is obviously quite not possible. it's actually possible at some temperatures. Okay, uh, in future you will be learning about Boyle's temperature. Okay, where at the temperature your what do we say, uh, any gas acts as uh, ideal gas at that temperature, at that particular temperature. That's what your Boyle's temperature is. Now with this we can come to another fact that Z equals to PV by nRT. Okay, so this is where you know this Z is actually called as compressibility factor, and for ideal gas it's always equals to 1 because PV equals to nRT, and the ratio between PV and nRT is your compressibility factor. Okay, next, values of R. Well, so R is 8.314 even it's in atmosphere. The important thing is the units of R. The temperature units are always taken in Kelvin. Let me write it. Temperature units always Kelvin. So when you do any question, when it's given in even Celsius or if it's given in Fahrenheit, you need to convert the temperature into Kelvin. That's must. That's a convention which we take. Okay, and pressure can be given in bar or atmospheres. Okay, next, your volume can be given in meter cube as you saw in the above question, or liter, something like that. Okay, and number of moles doesn't have any unit because while you study dimension chapters in your physics, it's given weight by gram molecular weight and both are weights, so there is no this. And what will be the units of R? R is simply PV by NT, that means atmosphere into liter by and Kelvin inverse. Atmosphere liter Kelvin inverse. Similarly, in terms of bar, it is 8.314 into 10 power minus 2 bar liter Kelvin inverse. And there are even some more other units. Sometimes the pressure might be given in pascals or torr, something like that. And your STP conditions are 25 degrees Celsius, which is 298 Kelvin, and 1 atmosphere pressure, and 22.4 liters is your volume. Okay, and number of moles will be equal to, then obviously your R value will be 8.314 into atmosphere liter Kelvin. Okay, so coming to the question. Let me copy paste this. Okay, so let me once again read the question. See, the question says that you are having two compartments A and B, both are actually filled with oxygen gas, and you need to assume that the behavior of oxygen is ideal in nature. Okay, that means PV by nRT equals to 1 because the compressibility factor is 1, right? Okay, so they both are actually separated by a heat insulator. I mean, perfectly heat insulator. That means temperature difference, like temperature doesn't flow from A side to B side. We know that anything requires some potential, and potential is always if something flows from a higher one to the lower one, that's the potential, right? So here also we are having 400 Kelvin, and here we are having 300 Kelvin. So when you actually replace this slider with another one which is movable, then it will move like this, right? and and it's saying that if the partition is replaced by new partition which can slide and conduct heat but does not allow gas to leak, the volume of the compartment A after the system attains equilibrium is. Okay, so what can you actually say? See, it says that it doesn't conduct heat, right? So you can say that it actually moves. Why does it move? Because of the pressure difference which we are having here, from pressure difference and the temperature difference, because before it was a perfect heat insulator and now it's not a perfect heat insulator. So due to pressure difference it will mono, and due to the temperature difference. So first we shall be finding number of moles of A and number of moles of B. How do we find it? Simply we'll use the ideal gas equation. PAVA will be equals to NARTA, right? So your NA will be PA by RTA. Substituting those values, it's 1 bar into 400 Kelvin. Sorry, what's the okay, 5 bar and 1 liter, right? It's 5 bar 1 liter, and R times what's the temperature there? 400 Kelvin, right? So Na is 5 by 8. One by 80 R. It's the number of moles. And NB, PB, VB equals to NB RTB. Simply you're just putting the ideal gas equation in this one. Then what are you actually finding? That NB will be equals to PB VB by RTB. What are the values of PB, VB and RTB? They are 1 bar into R 303. This, I guess, yeah. So NB value is 1 by 100 times R, right? This is the value of NB. Now initially those are your number of moles of A and number of moles of B, right? Next thing is that A and B, right? The slider is actually replaced by another one, and both the compartments actually attain equilibrium when the slider is replaced with the other one, which allows the heat to conduct. Why does the slider move? It's obvious that here the pressure is like 5 bar and here the pressure is 1 bar due to the pressure difference, and that we all know that gases expand on heating, right? So similarly here they both are the driving forces why this one the slider moves, because A has higher temperature and pressure, so the slider moves. So how much will the volume be? Initially B has some 3 meter cube. Now let us assume that the expansion will be some x meter cube. Where will the gas expand? A, because it has higher temperature and higher pressure. So we all know that gases expand on heating. And here 400 Kelvin is greater than 300. So obviously gas A will expand. Then what will be the final volume of gas A? It's 1 plus x. And what will be the final volume of gas B? It's 3 minus x. Okay, all clear? Because x liter has been expanded, right? That's why, you know, uh, expansion will be just adding them and subtracting. Okay, now he told that, you know, equilibrium is attained. And he also told that, you know, this, what do we say? Yeah, there is no gas leak. That means number of moles will be constant. So Na plus Nb is always constant. Okay. So with this, I will write that P1 V1 by Nr T1 equals to P2 V2 by Nr T2. Right. And at equilibrium, volume is obviously that 1 plus x and 3 minus x. And the slider eventually stops at one point where the pressure and temperature both are equal in both sides, because that's what equilibrium means, right? uh, they both will be, neither there is any exerting from a force from A, or neither it's exerting force from B. So with this I can cancel out P1 P2 and T1 T2. Then you're eventually left out with R, and sorry, R is a constant, so this is what happens. Then it is simply V1 by V2 equals to N1 by N2, right? What is V1? It's like one, for, what do we say? Uh, for compartment A, the volume is 1, and for this, again, we are just seeing it, in the compartment A itself, because he asked us to calculate the volume in compartment A, right? So this will be 1 plus x, and first initially it was 1 by ATR. Now the total volume will be 1, I mean total moles will be 1 by ATR plus 1 by 100 R. This will be cancelled. Yeah, okay. So I'm actually a bit sorry that I had committed a mistake, that what I told that was, we was only comparing it between uh, only between the compartment of A, right? Which is actually wrong. That, at equilibrium we are seeing this condition satisfies between the both the this, what do I say, compartments. That means, you know at compartment A and at compartment B, Na by Nb will be equals to Va by Vb. This is the condition which will actually satisfy, which I actually, earlier I wrote that 1 by 1 plus x, which is actually wrong. And now at equilibrium, we are, you know, it's final one, the 1 plus x and 3 minus x one. Okay. Fine. So it's Va and B equals to Vb and A, right? So Va and B, right? Va is that we know that it's 1 plus x, and Nb is 1 by 100 times R, and Vb is 3 minus x, and Nb is NB is 1 by 10, 1 by 8 times R, right? Right? Let me check it once. NB is 1 by 100 R and N is, yeah, we are going in right direction. Then this cancels, and what is left is it's 5 times, it's 4 times. So 15 minus 5x is equals to how? 4 plus 4x. That implies 9x is equals to 11, and x will be 11 plus 11 by 9. And your final volume is VA, that is 1 plus x, that is 1 plus 11 by 9, which is approximately 2.2. Right. This is what there was a mistake there, which will be rectified, which I rectified. And now they asked us the final volume of this. This is the answer. Yeah. So thank you guys.